Alright guys, during my previous video I made a video on that Euler substitution for integration, right? And I told you guys I'll be dropping a particular example to solve it. And the only one I did was the Euler's first sub, which we'll be talking about today. And how do you use the Euler first sub for integration? It's a process whereby you are automatically, this is a normal term for it, but a process whereby you're having the a greater than 0, you can apply the Euler first sub to it. And automatically our a is greater than 0 here, which is equals to, our a is equals to 1 here. That's coefficient of x squared. Now, before I move on, I want to quickly explain something. That is integrating something like, let's say 2 dt over t squared plus 4. I will really need this. That's what I want to quickly just explain now before we move on, so that I won't waste my time on it. Now, guys, this is automatically looking like a tan inverse, yes. But how do you process it into it to make it something look like this? Let me just say 1 over s squared plus 1. Let me just say then dx. How can you make it look like this? That is what we are after before we can deal with some other things. So quickly, don't let us waste time. This will be 2 integrating 1 over t squared plus 4 abi our dt, and this will be equals to 2 integrating your 1 over 4 into bracket t squared over 4 plus 1, right? Automatically this will give us t squared plus 4 back now. Then dt. Now this will be your 2, this 4 will come out also, that will be 2 over 4, and that will give us automatically 1 over 2. Integrating 1 over your t squared can be breaking down as t over 2 raised to power 2 plus this is not 4, this is plus 1, so plus 1 our dt. Are you with me? Then now it's already making sense. Now our u can be equals to t over 2. Now this process, people do make a lot of mistake. I saw a particular guy, the guy was trying to use quotient rule to differentiate this. Now guys, this is automatically normal thing like you having 2t. So this is just like you saying u is equals to 1 over 2t. Then differentiating that will give us the u over the dt being equals to 1 over 2. So our dt automatically will be equals to, that's dt will be equals to 2 du. Take note of that. So u differentiating this would give us 1 over 2, then dt will be equals to 2 du. Like I had said, it is making some sense. And that will be 1 over 2, right? Our dt changes to 2 du. That will be integrating 1 over t over 2 becomes u squared plus 1 times 2 du. And so these two also move forward again back to here, back up here. That will be 1 times 2, and 2 divided by 2 will give us automatically 1. So it's just like you integrating your 1 over u squared plus 1 then du. And what do I tell you guys? Integrating that makes it look like I said, this is now the same thing as this. That will just be equals to tan inverse of our u, and that will be equals to, let me just put the c also with it, and that will be tan inverse of our u is what, guys? That's t over 2. That will be tan inverse of t over 2 plus our c. So actually just drop it down so that we can quickly talk about it. So I guess you all understand the steppings to get the integration. So I'll just put it that integrating this, because I actually need it, integrating 2 dt over t squared plus 4 would be equals to tan inverse of the t over 2 plus our c. So take note of that. Now let's move on to solving our question. Moving on to solving our question now, from here, like I said, if you had checked my previous video, you understand what I'm about to do. Plus 4x minus 4. I told you guys in the previous video that this can be plus or minus, but let's just use plus. And that will be, x root a, and our root a is root 1, which will give us automatically s plus t. Square both sides, this will become x squared plus 4x plus minus 4 being equals to, you have s plus t squared, as we all know, right? And having s plus t squared would become s squared plus 2xt plus t squared, and this cancel out this, you'll be having 4x minus 2xt equals to your t squared plus 4. It's making sense now, right? And that will be s into bracket 4 minus 2t equals to t squared plus our 4. So therefore our x now will be equals to t squared plus 4 over 4 minus 2t. We are getting to somewhere. So we've gotten our value for x now. And mainly the question sends us that, I know send email you find only s, so you guys find this one for me too. And what's the value for this one? Is x plus t, abi? So finding our x plus t now, this can be equals to our x now is t squared. I mean that is t squared plus 4 over 4 minus 2t. So plus our t now, this will just be giving us 4 minus 2t. Are you with me? Then t squared plus 4 and 4 minus 2t, then this will give us 4 times t plus 4t, right? Then minus 2t, this will give us minus 2t squared. Are you with me? So take note of that. I'm trying not to waste time about this. So looking at this changes to minus 2t squared. This will give us minus t squared plus 8t plus 8. Okay, so one more time, this is automatically our t squared plus, then adding t to it, you have your 4 minus 2t, right? Then this will be t squared plus 4 and also 4t, and having your 4t, let me just break it down normally. So that will be our what do they call it, t squared. Are you with me? T squared plus your 4 over 4 minus 2t. So this will plus the t, and that will be equals to your 4 minus 2t, which will give us t squared plus 4 plus 4 in 1 this time. This will give us 4t. Are you with me? 4t, then your 4t plus our, what do they call it, our 2t squared. So like I said, this would be t squared plus 4t. This will be okay, minus 2t squared, sorry. This will be minus t squared plus 4t plus 4. So minus t squared plus 4t plus 4. That will be minus t squared plus 4t plus 4. Without not wasting our time. Minus t squared plus 4t plus 4 over 4 minus our 2t. So moving on to this, guys, you can now easily integrate your function as okay, we need to differentiate also because of this dx here. So differentiating this now, our dx over dt, is with respect to t. You'll be having v, then du. This is u, then this is your v. So v du dx, you'll be having 4 minus 2t. Are you with me? V, then du dx, this will give us 2t minus u, which is this idiot here, t squared plus 4, and our the v over the t, and that will give us ordinary minus 2 over our v squared, which would be 4 minus 2t raised to power 2. So moving on, guys, without not wasting time, you don't have to sleep, and our dx over the t would simply be equals to, this will give us 8t minus 4t squared. This will give us minus 2t squared, then times this minus, that will be plus 2t squared. This will give us minus 8, then times this, that will be plus 8 over 4 minus 2t raised to power 2. Are you with me? 4 minus 2t raised to power 2. So we can break this down as dx over dt would be equals to minus 4t squared. This will become minus 2t squared plus 8t plus 8 plus 8t plus 8 over your 4 minus 2t raised to power 2, right? So automatically, we are not looking for dx over dt. We are debunking on ordinary dx. So therefore, your dx would be equals to the same value here, which is minus 2t squared plus 8t plus 8 over 4 minus 2t squared, then your dt. Are you with me? That is plus our attaching our dt. So we've gotten the first, we've gotten this, and we're also getting this. Now let's move on to the main important thing now. Integrating this function 1 over x roots x squared plus 4x minus 4, that's the x, will change to something like this. Now, you know, this 1 times dx is also the same thing as just saying the x at the top here, so don't confuse yourself, say the same thing. So this will be equals to, so just like I said, Then moving on to this now, this would be giving us our dx is minus 2t squared plus our 8t, then plus our 8 over 4 minus 2t, then square. Now divided by our x now is, where is that idiot x? T squared plus 4, over 4 minus 2t. Then this gives us minus t squared plus 4t plus 4 over 4 minus 2t. So without not wasting our time, guys, this is making some sense. This is making some senses, and this could be equals to, you can have your 2 outside here, then our okay, so this is the t. It has changed to be able to the t because we are expecting with t now. We are expecting t as an honored guest. So that will be minus t squared plus t plus 4t, then plus 4, right? Putting general now. Putting general, man. Alright, you have 4 minus 2t squared. Then this should be divided by, this would be inside brackets as t squared plus 4 and minus t squared plus 4t plus 4 over, you'll be having 4 plus 2t squared. Now we all know the law of, what do they call it? Our normal law for fraction. And sorry, I ignored the integrating value. This is integrating. Sorry about integrating, how it looks like. So this is just like integrating, also integrating our value. So sorry about that. Take note of that. Everything into brackets with your dt. So this would become this is a 2 here, which is a constant. So the constant can come to the front. Then you can integrate. You'll be having minus t squared plus 4t plus 4 over 4 minus 2t squared. Then times this will move up now, as we know, law our fraction normal division law, over your t squared plus 4, then minus t squared plus 4t plus 4. Now, like I said, this is making some senses, much more sense, a lot of senses inside the sense. All right, guys, this will cancel out this, and this will also cancel out this. You'll be having this being equals to 2, integrating, this becomes 1 over our t squared plus 4, then dt, your dt, dt. So I told you guys something like that this will look actually like this, and as you all know, I've explained this already right from the beginning, right from onset, and these two just come to the front here. Without not wasting our time, this will actually be equals to tan inverse of what? T over 2 plus c. But we are not done yet. We have to know our tan, our what do they call it? Our t. And I told you guys that this s plus t is just the same thing as something you have here, right? Then coming back to this s plus t, if you shift x to this side, you'll be having it being equals to tan inverse of our t now will become square root of x squared plus your 4x plus your 4 minus your 4 rather, minus your 4 what's it on again, right? All right, minus your 4, then minus the x, which will come to the back there, then over our 2 plus c. So can you see how simple this is? And that is our answer for the question. Thank you. You all are welcome to Clipto's World. We see next class where I'll be explaining the Euler second substitution and our normal simple example on it. Thank you.